So this is the first of 2 lessons on what we call integral exponents, which means integer exponents. Now, remind you, an integer is a whole value, so there's no fractions or decimals, but integers involve the negatives. So again, 5 is an integer, but also -5 is an integer. And so really main part of this is understanding what it means when we have negative exponents and what that means. That's it. Let's start with 0, which is an integer. And remember, 2 to the power of 0 equals 1. And essentially anything to the power of 0 equals 1, because I'll make a little note here. X, anything to the power of 0 means x divided by itself, or x over x, which always equals 1. As long as this x, as long as this number is not 0. Okay, so I'll say as long as x does not equal 0, then x can be any real number. So I'll write that in blue just because everything else is in blue. So x cannot equal 0, but other than that, x can be any real number. And so that phrase, or this symbol here, that x can belong to the real numbers, we saw that earlier on in the course. That just means literally, that x that I've highlighted multiple times in yellow, this is that statement, x to the power of 0 equals 1 is true for any number you can think of except 0. 0 to the power of 0 is undefined, because essentially it means dividing by 0, which doesn't make sense. All right, so that's a power of 0. A power of 0 equals 1. But what does a negative power mean? What does 2 to the negative 3 mean? Well, 2 to the positive 3 means 2 times 2 times 2. Or another way of looking at 2 to the positive 3 would be to say that 2 to the positive 3 is the same as 1 times 2 times 2 times 2. All right? Now, we don't usually talk about the 1 in the front because we don't need it there, but it's not wrong, right? 2 to the positive 5 means 1 times 2 times 2 times 2 times 2 times 2. So what does 2 to the negative 3 means? Well, it means 1 divided by 2 divided by 2 divided by 2. Right? So I'll write that out right here. 2 to the negative 3, we can think of it as it meaning 1 divided by 2 divided by 2 divided by 2, which is kind of a messy way of saying 1 over 2 to the power of 3. Dividing by 2 over and over again is, what I have right here, divided by 2 3 times, is the same as what I have right here, dividing by 2 3 times, 2 to the power of 3. But I'm dividing by it. Now, in this case, this does equal 1 over 8, but I don't really care too much about that. I'll write it down, but I care more about the first thing I said, which is that 2 to the negative 3 is the same as 1 over 2 to the positive 3. Essentially, a negative exponent means repeated division, whereas a positive exponent means repeated multiplication. And all division can be shown as a fraction. And so, in general, x to the negative a is the same as 1 over x to the positive a. And we saw the same thing up here. 2 to the negative 3, same as 1 over 2 to the positive 3. And this is the core part of this first lesson dealing with negatives. A negative exponent means repeated division. And division can be shown as a fraction. Okay? And that's all I'm going to do for now. Okay? There's more to it, but that's the key part, what I have right there. A negative exponent means repeated division. So let's evaluate some of these. So what does 4 to the negative 2 mean? I'll mention a common mistake, and a common mistake is negative 16. But 4 to the negative 2 means 1 divided by 4 2 times, or 1 over 4 to the power of 2. Now, 4 to the power of 2 is 16, so I could rewrite this as 1 over 16. And I do ask to evaluate. Evaluate means find the value, calculate. And so 4 to the negative 2 is 1 over 16. 4 to the negative 2 means 1 divided by 4 twice. But I would encourage you to write down these common mistakes, because you'll almost certainly make them at some point. So a common mistake is negative 16. Again, a negative exponent has nothing to do with negative answers. A negative exponent means you're repeatedly dividing. All right, so what does 2 to the negative 3 mean? It means 1 divided by 2 divided by 2 divided by 2, which is the same as 1 over 2 to the positive 3. Which is the most important part to me. That's it. 2 times 2 times 2 is 8, so I can write it as 1/8. That's it. A common mistake. Hopefully you can kind of guess. A common mistake is I think this equals -8. And that, again, 2 to the negative 3 means literally what I wrote down there. 1 divided by 2 divided by 2 divided by 2. And if you take 1 and divide it by 2 3 times, you get an eighth. Okay, what about 10 to the power of 0? That equals 1. That's it. That's it. A common mistake is to think it equals 0. So I highly, again, recommend you write that down. But anything to the power of 0 equals 1. As long as it's not 0 to the power of 0, anything to the power of 0 equals 1. Easy to forget, but also easy to work out. Okay, negative 5 all to the negative 2. So what does this equal? Well, this means 1 divided by negative 5 twice. Okay, so this means 1 divided by negative 5 2 times. Those brackets are key. It's negative 5 divided by negative 5, right? The whole base was negative 5, so all negative 5 is here. To a power of negative 2 is a positive 2. And those brackets are important because negative 5 times negative 5 is positive 25. A common mistake is to think this is going to equal negative 1 over 25. Because, again, if we don't have these brackets, which is wrong, we get 1 over negative 5 squared. And negative 5 squared is negative 25. Negative 5 squared, we saw this last day, means negative 5 times 5. That's what it actually means. And if you use your calculator, it's going to tell you the answer you don't want, which is negative 25. And again, we don't need a calculator for this. So again, the whole thing, negative 5, is being raised to the power of negative 2. So the whole thing is being divided by twice. And again, you divide by negative twice, it makes sense we get a positive number. Okay, what about negative 5 to the positive 2? Well, that's just 25. Common mistake is to think now this is going to be 1 over 25. What starts to happen now is students start to see negatives and they just make things fractions. But again, this is a negative base, not a negative exponent. Okay? And now this mistake of thinking that this equals this, I never see in a grade 8 or grade 9 class because we don't work with negative exponents. But once we start working with negative exponents, students start to mix up a few things in their head. And anytime they see a negative with exponents, they just make it a fraction. But again, if you look at these two, if it was 5 to the negative 2, that is the same as 1 over 25. But it wasn't 5 to the negative 2, it was negative 5 to the power of 2. And again, those little details we have to be clear about. I mean, it's all about these little details. But literally, that just means negative 5 times negative 5. Lastly, I've kind of spoken about this already a few times. Only difference with this last one is there's no brackets. So this literally means 5 times 5 with a negative in the front. 5 times 5 is 25 with a negative in the front. The common mistake is to think this equals 25. Which again, that would be correct if there was brackets around it. That was the last one. All right, let me make this a little bit more involved for the last set. Okay, so I got 6 here. I'll do these one at a time. So this time I want to simplify, which means I'm not asking us to evaluate and get some number. I just want to write it in a simpler form. Okay, and sometimes there's more than one final answer. That's kind of considered simplest. And so let's start with this one. 6 to the power of 2 times 6 to the negative 7. Well, notice I am multiplying powers with the same base. And you've learned before, we've reviewed already that when you're multiplying powers with the same base, you can add your exponents. So I can rewrite this as 6 to the power of 2 plus negative 7. 2 plus negative 7 is negative 5. And so I can write this as 6 to the power of negative 5. That is a great answer. However, in this class, generally, it'll be pretty rare that I'll ask you to leave your answer as a negative exponent because I want you to show me that you know what a negative exponent means. And honestly, you're probably going to be unsure at times what a negative exponent means. So while this is great, what does 6 to the negative 5 mean? It means 1 divided by 6 5 times. And so for the purposes of this course, this is the sort of answer I'll usually want when I want you to simplify something. And you'll see it a lot in the homework, and you'll see it when I assess you. There'll be times I ask for your answers to be written with only positive exponents, not negative exponents. Nothing inherently wrong with a negative exponent, but I want to see you know what it means. So in the end, that's the sort of answer I want there. Okay, let's look at this one here. 4 to the 3 divided by 4 to the negative 2. Well, I'm dividing powers with the same base. And so when you're dividing powers with the same base, you can subtract your exponents. So I can write this as 4 to the 3, take away negative 4. 3 subtract negative 4. I got a double negative right here. When you're subtracting negatives, same as adding. So I can rewrite this as 4 to the power of 3 plus 4. Right? Subtracting a negative, always the same as adding, which is 4 to the power of 7. And again, I'm just going to leave it there. I'm not asking us to evaluate. I just want us to simplify it. And 4 to the power of 7 is simpler to understand than 4 to the power of 3 divided by 4 to the negative 4. All right, let's look right here. I want to simplify it. So how do I do this? Again, what I'm really doing is essentially connecting what we reviewed last time about our exponent laws with dealing with negative exponents. And so I have factors here all being raised to a power of negative 3. So let me think of each of these separately being raised to negative 3. And so I get 2 to the 3 times negative 3 is negative 9. Right? When you have a power raised to another power, you multiply the exponents. Times, I have 4 to the negative 2 times negative 3 is positive 6. It's all good. But again, all that's left now is this 2 to the negative 9. Again, there's nothing wrong with it inherently, but I want you to be able to show me that you know what a power of negative 9 means. And 2 to the negative 9 means 1 divided by 2 9 times. All times 4 to the power of 6. And so lastly, it's kind of silly to leave these two fractions separately, especially if you think of this as 4 to the power of 6 over 1. When you're multiplying with fractions, you don't even need a common denominator. So I have 1 times 4 to the power of 6 in the numerator. I'll leave it as 4 to the power of 6. And I have 2 to the power of 9 times 1 in the denominator. And that is the answer I want. So more and more, our work is connecting different lessons together, especially going back to the key things we reviewed on exponent laws. And if you haven't taken a look at the video where I review exponent laws, look at that. Okay, we review the key ideas from Math 8 and especially Math 9, which I'm using now a lot. All right, last 3 here. I want to write this without any negative exponents. And so now it's all variables in terms of my bases. But really, I just want to focus on this y to the negative 3. What does y to the negative 3 mean? It means 1 over y to the positive 3. 1 divided by y 3 times x squared. Well, at this point, we saw how easy it is to put these together. Essentially, this is the same as x squared times 1 in the numerator and 1 times y cubed in the denominator, and I'm done. Ideally, this is only the day 1 of doing this, but ideally, fairly soon, you'll be able to go from here to here really, really, really quickly. Ideally. Maybe not today, but again, ideally, we can kind of skip that sort of step there. All right, let's look at the second last one. 2x squared times y to the negative 3. Again, in terms of simplifying, all I want to do is rewrite the negative exponents with positive exponents. And so it's just this y to the negative 3, which again, y to negative 3 means dividing by y 3 times. Now I still got the 2x squared right here. And so put this all together. My numerator is 2x squared. My denominator is y cubed. And again, like before, I'm hoping without too long, you can go from here to here almost immediately. Just realize the y to the negative 3 part is the same as dividing by y 3 times. Okay, that's it. If we do it in 2 steps, it's not a big deal. It doesn't take that long. But eventually, I'm hoping we can skip that middle step. Last one. Okay, all of this to the power of negative 1. A few ways of approaching it, but what I would do is I would literally show all my factors, 2x squared and y to the negative 3, all being raised to the negative 1. Quite often students will forget about the 2 right there. That's it. 2 to the negative 1 is 2 to the negative 1 times x squared to the negative 1 is x to the negative 2. Again, you multiply your exponents. And y to the negative 3 to the power of negative 1, multiply your exponents, is y to the positive 3. All right, so all that's left now is dealing with my negative exponents and finding a way to rewrite them. So I have 2 to the negative 1, and I have x to the negative 2. Those are my only negative exponents. And so if I look at this, 2 to the negative 1 means 1 over 2. Or 2 to the negative 1 means 1 divided by 2 one time. 1 divided by 2 one time is 1/2. So 2 to the negative 1 is another way of writing the number 1/2. They're exactly equivalent. 1/3, the fraction of 1/3 can be written as 3 to the negative 1. They mean the same thing. Probably didn't realize that till now, but going forwards, we want to kind of realize that we can write, use negative exponents to show division. And so that's it. I also have x to the negative 2, same as 1 over x squared. And then just my y cubed, which already has a positive exponent. So clean this up, put it into a single fraction. I have just y cubed in the denominator, 1 times y cubed. Sorry, in the numerator. In my denominator, I have 2 times x squared. And again, like I keep saying, I'm hoping eventually we can skip one of these steps in the middle and get straight to this. Kind of go straight from here to here. I'm hoping eventually. And we're going to spend a couple days on this. So right now, while I did this fairly quickly, that's because you can pause this video and go back all you want. This is something that students tend to struggle with, and that's why I'm only doing a bit today, and we're going to spend a few lessons on this idea of dealing with negative exponents. But it's one of the key ideas, and it's, for a lot of students, it's one of the more challenging parts. But with a bit of practice, it definitely gets easier. We definitely need some practice. Okay, and the good thing is you can look at these videos all you want. That's it. I'm done.